Alright, what is up everybody? I am Jay Coding, and this video is about Pemdas. This will be the second lesson in the AP Computer Science series, so let's get right into it. As you guys know, Pemdas could stand for Please Excuse My Dear Aunt Sally, or, as most people know it, it stands for parentheses, exponents, multiplication, division, addition, and subtraction. So now I will be teaching you guys how to use Pemdas on Java. First thing I have to do is declare my variables. I'm declaring my variables using a double. Now, as you guys know, a double, I can use a decimal using a double. And I listed I want double A, B, C, and result. So I said A is equal to 1.5, B is equal to 2.5, and C is equal to 100. Now we're going to test the various way Java uses Pemdas, how specific we have to be with the parentheses, how literal it takes multiplication and division. So now let's start off with this simple code. Let me just comment this out. For those of you who don't know, a multi-line comment is a forward slash and a star. And you can end it with a forward slash and a star. Okay, so over here, I set result is equal to A plus B times C. So now it'll add 1.5 plus 2.5. And I'm going to set C to 100. 1.5 plus 2.5 is 4 times 100. It should equal 400. Let's see. And it equals 400.0. Now the reason it adds 400.0 is to add precision, just because we did set A, B, C, and result to a double variable. So Java will be as precise as possible. Let's see, I wrote a note here earlier. Now I can remember. Let's try numbers 5.3 and 6.7. Let's see what happens. 5.3, 6.7, so that should be 12. Yes, times 100, 1200. Now this could really work for anything. 100.567. You get this. So now let's set these back to what we previously had. Now let's try to do A minus B times C. You get 400.0 and negative 100.0. What it did was 1.5 minus 2.5, which is negative 1, times 100, which is C, and it came out to be negative 100.0. Now, as you guys can see here, I did println result, and as we go on, the value of result keeps on changing. So over here, I set result to A plus B times C, and I printed out what result is. And as you guys know, Java interprets things literally, not as a whole. So it goes line by line, interpretation by interpretation. So once it was done interpreting it, it goes to the next line over here, line 11, and it interprets result now as A minus B times C, and it prints out the new value of result. So now let's try this again with 5.3 and 6.7. Now, this is interesting. Why did it print out negative 140.00003? Now, I wrote a note here earlier. It all depends on your interpreter. So I have a Mac interpreter. Some people have a Windows interpreter. So my Mac obviously runs under Mac OS. There's Windows, there's Linux, there's Unix. Java just tries to add precision just because that's the way Java is. That's how it works. And that's how it works with a double. Now, let's try this. We set result equal to A plus B divided by C. Now obviously it does B divided by C first, and then it adds A. So now let's put back our old values, 1.5 plus 2.5. So now it will do 2.5 divided by 100, and then it'll add 1.5. So it should be 1.525. Let's run this. 1.525. Now we have a tricky one over here. I'm not calling any variables in this one. I'm just typing it in the print method exactly what I want to see. So let's see what this prints out. It's 50 plus 100 divided by 10 minus 5 plus 7 mod 2. Now, some of you guys might be confused because you guys know that the mod operator prints out the remainder. In this case, it doesn't print out the remainder because there's all these other commands inside of it. If I just did 7 mod 2, there would be a remainder in it and it would only print out the remainder. But as of right now, it'll print out the actual value of 7 mod 2. So that would be 3.5. So try to figure this out on your own, how Java could have interpreted this command right here, just to see how we got 56. To give you guys a hint, use Pemdas. Now we'll do this last line of code over here. 4 times 2 times 5 mod 6. Now as you guys know, 6 goes into 5 0 times, and 5 is the remainder. So it should multiply 4 times 2 times 5. Let's see. Yes, 40. Well, I hope you guys enjoyed the video. Thanks for watching. Peace.